11.2, 11.3, dividing polynomials. In this section, we're going to be using what we did in Chapter 8 with factoring, and we're going to divide out common factors. All right, so when we are dividing, recall that the rules for dividing variables with exponents, you divide the coefficients, or the big numbers, and you subtract the exponents, or the little numbers. If there are negative exponents, they move either to the top or the bottom, depending on where they are to begin with, and then they become positive, and then you can simplify. So if you're looking at this example right here, for x cubed y to the negative first power over, or divided by 6xy squared. 4 and 6 are your coefficients, so you can go ahead and simplify them. You can put them in your calculator or simplify them by taking a 2 out, and you will be left with 2/3. Then you need to look at the variables. I have an x3 at the top and an x1 at the bottom, so I subtract those and the number goes on the top because it's positive. And then the y, I have a negative y. I'm going to move it down to the bottom to make it positive. And when I do that, now it's multiplying variables with exponents, so you add them. So that becomes y to the third power. So the final answer is 2x squared divided by 3y cubed. All right. Also recall that when we are dividing fractions, we really are multiplying by the reciprocal. So we would change the division sign to multiplication and flip the second fraction. So that would become 2x divided by y times x divided by 1, which is equal to 2x squared, and y times 1 is y. And that is already simplified. So you'll be using both of these rules, all the rules of the exponents, but both of these things in this section. So when we divide a polynomial by a monomial, we divide each term of the polynomial by that monomial. You can split it up if that helps you, or you can factor before you get started. So what I've got you shown here is where it's all split up, but let's do it as if we were going to factor. So let's just focus on the problem. What do you see in common in the top alone? Okay, we definitely have 3, and we also have an x in common, so we're going to take a 3x out. And if we take a 3x out of 27x cubed, we're going to be left with 9x squared. All right, if I divide a negative 9x squared by 3x, then that's going to leave me with a negative 3x. Okay, and then when you divide 3x divided by 3x, it's going to leave you with a 1. All that over 3x. Now you need to always check to see anything that's left in the parentheses once you take things out, if it can be factored. 9 times 1, because it's a type 2, we do 9 times 1, which is 9. Factors of 9 that add to be 3, and there aren't any, so we know that is completely done. Now once you have it to this point, you go ahead and cross out stuff that's in common. Well, this 3x go away. And that'll leave you with just 9x squared minus 3x plus 1 as your answer. Now, we're also going to be talking about domain and the domains of these rational expressions. All right. Domain, when you're talking about that, you can have any real number except for anything that will cause the bottom to be 0. So is there any number that would cause 3x to be 0? Of course, if I put a 0 in for x, that would be 3 times 0, which would make 0. So x cannot be 0, because if we had a 0 on the bottom, that would make this undefined, and we know we can't divide by 0. Bad things happen when you divide by 0. So the domain is all numbers, but x cannot be equal to 0. So in other words, that gives it a limit and it excludes 0. Any other number but 0 will work. Okay? All right, to divide a polynomial by a polynomial creates these rational expressions. Rational expressions is just a fancy word for things that look like they're in a fraction. To do this, you're going to factor, and once everything is factored, you cancel out things that's in common between the numerator and the denominator. If you have a GCF in the numerator and denominator, you need to simplify that fraction. All right, so I'm looking at this, and I have 3x minus 6. All right, so what can I take out of just the top? Okay, we'll just work at the top first and the bottom, and then we'll look at things together. That one has a 3 in common, so I'm going to take a 3 out, and I'm going to be left with x minus 2 divided by. And then this is a factoring type 1 problem. So you can go ahead and make your bubbles. All right, your signs are going to be opposite because there's a minus in the back. You split up your x. And then you say factors of 6 that subtract to be 1. There's really a 1 right there. Factors of 6 that subtracts to be 1. Now that would be 3 and 2. And then 3 is bigger than 2, so 3 will get the sign that goes right there. So that would be a positive 3, a negative 2. Okay, now once you have everything factored and simplified, then you can cancel things out. I have an x minus 2 here and an x minus 2 here, so I can cancel those out because they would just make 1. Okay, and then that leaves me with my final answer as 3 divided by x plus 3. And you multiply across the top, and all I have left is the 3. And you multiply across the bottom, and all I have is x plus 3. Now, when we're talking about restrictions on the domain, we can have domain can be all numbers, except x cannot be what? Well, down here, if I had a positive 2, that would make this 0 times this, and anything times 0 would be 0, so x cannot be 2, and x cannot be negative 3. Anything that makes a 0 on the bottom will restrict your domain, okay? So x cannot be 2 or negative 3. So if you want to, if it's easier for you, set each part on the bottom equal to 0 so that you can see the thing that would become the restriction. You can do that. Okay, but this is what causes it to be restricted. So the domain can be any number except x cannot be 2 or negative 3. All right, the next one, and I'm going to erase some of this out of the way so we have room to work. The next one says x minus 1 divided by 5x minus 5. Well, the top is already simplified as far as it can be, and remember, it is a quantity. I like to keep them in parentheses. I think it's easier to see that way. And then I notice I can take a 5 out of the bottom, and when I do, I'm going to be left with x minus 1. All right, when we simplify, these will go away, and my final answer will be just a 1, and then 5 on the bottom, so 1/5. But as far as the domain and being restricted, x cannot be, what would make this 0 down here? X could not be a 1. So I had a 1 there, that would make 0. 0 times 5 is 0, so x cannot be 1. Okay? Next problem, similar, except for you're going to have to work on the top and bottom. Take a 2 out, and you're going to be left with x minus 4. On the bottom, you have a type 1 problem, so you can go ahead and set up your bubbles. Opposite signs, because there's a negative in the back. And you say factors of 8 that subtract to be 2, which is 4 and 2. Now, because 4 is bigger, it gets the sign that's right here. So that is going to be a 4 and a 2. Alright, so I can cancel out these 4's, and I'll be left with 2 over x plus 2. Now remember, this is a quantity. You cannot cancel out these 2's because this is glued together and this is by itself. Okay? Now, as far as the domain, is all numbers except x cannot be, what would make it 0 down here? Positive 4 and a negative 2. Positive 4, negative 2. Okay? Alright, next slide says a little bit more. We're doing multiplication because we can't really divide fractions. So right now, this is really showing this is over top of 1. Because anything you have, you can put over top of 1. And then that way you can change it to multiplication and flip it, which is what I did here. And then you have to simplify your parts. So I'm going to simplify this part right here by taking out a 3x, leaving me with an x minus 4 all over 5x times 1. And this after has to be factored. Opposite signs because it's a negative in the back. Split up your x. Factors of 4 that subtract to be 3, which would be 4 and 1. And because this sign's right here and 4 is the biggest, 4 gets the negative. Okay? Now, you can cross reduce on this because we are multiplying fractions, so that would mean this would go away. And that leaves me with 3x times 1, which is 3x, and 5x times x plus 1. Alright, now I notice that I have an x and an x, so that needs to go away also. So that leaves me with 3 over 5 times x plus 1. And don't distribute it back through. This is the final answer. Now, going back over here, what would mess this up is if x was equal to, x cannot be equal to 0. Okay, because if I did that and then multiplied it to this, it would make 0. X cannot be equal to positive 4. That would make that 0. And x cannot be negative 1. All of these would restrict the domain. So domain is all real numbers except 0, 4, and negative 1. Okay? Now, what happens if you get something like this? You're tempted to mark them out thinking that they're the same, but really they're not. Why? Because this is a positive x and this is a negative x. This is a negative 3 and that's a positive 3. Now, most people like to have their variable on this side. So in order to fix this, we can switch this around by taking out a negative 1. Because when we do that, negative 1, taking out that 3 divided by negative 1 is going to make a negative 3. And a negative x divided by negative 1 makes a positive x over top of x minus 3. Now, because we have the symmetric property and it says you can switch things around without changing the signs, we can turn this around now and make it x minus 3 over x minus 3 with a negative 1 in front of that. Now they cancel, so my answer is just going to be negative 1. And on the bottom, x cannot be 3 because the domain would not allow it to be 3. X cannot be 3 because that would make it 0. Okay, so the answer is negative 1 and x cannot be 3 as far as your domain. Okay? Alright, I'm going to move this out of the way. I've got one more problem. Okay, the last problem says 1 divided by x minus 2 divided by x plus 3 divided by x squared, and this is a minus 4. Alright, when you have a problem like this is a complex fraction, and you really should rewrite it so you can see it better. So that's divided by x plus 3 divided by x squared minus 4. Okay? Now, remember, we can't divide fractions, so we have to flip it and multiply. So that's going to be 1 over x minus 2 times x squared, x squared minus 4 over x plus 3. Okay, and this is the only part that needs to be factored, and let's get a different color. Let's get this. All right, I'm going to change this to, how did I get my board turned all the way around? No wonder I'm writing crooked. This becomes x minus 2, x plus 2 when you factor, because this is a difference of squares. All right, so now I can cancel this out, and on the top I'll be left with x plus 2, and on the bottom I'm going to be left with x plus 3. Now, the domain is restricted where x cannot be 2 and x cannot be negative 3, because either one of those would cause the domain to be 0. Okay? And we will practice a lot of this in class. If you have any questions, please come in and see me before or after school. Thanks, and we'll see you in class.